Hello everyone, this is Mr. Molo for the 6.6 lesson, Geometric Sequences. Okay, so for this sequence, remember a while back we did arithmetic sequences, and we'll get back to that in a second, but these are geometric sequences. So this one's kind of tricky for two reasons. One, geometric sequences have to be a multiplying pattern. Okay, some of you are going to want to say it's a dividing pattern, but that's not what geometric sequences are. So make sure on big ideas and on the test, you're always putting it as a multiplying pattern. You'll kind of see here some of them, like number 1 here, it says we're starting at 2, and then we're just going to times by 2 each time. So we start with 2, and then times by 2. So we get to 4. Times by 2 again, we get to 8. Times by 2 again, we get to 16. Times by 2 again, we get to 32. But for problems like B here, it says we're multiplying by 0.5. So we need to write that we would multiply by 0.5, even though it looks like we're going to be dividing by 2. So remember, dividing by 2 and multiplying by a half are the same thing. Same thing, if you're like, oh, that's a dividing by 3, that's the same as multiplying by a third. Or dividing by 4, that's the same as multiplying by a fourth. So if you see a division pattern, make sure you're not writing divide by, you're going to flip it around and say multiply by that fraction instead. So 64 times 1/2. Well, first start with 64. So half of 64 is 32. Half of 32 is 16. Half of 16 is 8. And half of 8 is 4. And so kind of continuing on with that pattern there of multiplying by a half instead of the dividing by 2. Okay, and just like last time, there's going to be a formula that helps us figure out if they ask for like the 74th term. Okay, and it's going to be this one right here. So A1 times R raised to the n minus 1. So just like last time, A1, that stands for the first term. So whatever the sequence is starting with. R is kind of the same thing as our difference from last time. This is going to stand for our rate. So what is happening? What is it being multiplied by? Okay, and then n stands for the same thing it stands for last time. That's the number we are looking for. And then make sure you note that that is an exponent up there. It's kind of hard to tell with this writing here, but it's A1 times R and then raised to the n minus 1. So that n minus 1 is an exponent there. So you look here, it says determine whether the sequence is arithmetic, geometric, or neither. Okay, so now we need to go back. So if you remember, an arithmetic sequence has to be adding or subtracting. Geometric can only be multiplying, and neither means it's neither. Okay, so arithmetic, remember, has to be an adding or subtracting pattern. Geometric is only multiplying, and then we could have some neither problems here. So another reason I said geometric's more difficult for two reasons. One, because you have to think of multiplying. Two, because you can transfer and switch every sign like this one does. 1 to a -4 to a +16 to a -64. Some of you might be thinking, well, there's no pattern there because it keeps switching from positive to negative to positive to negative. But there really is a pattern there, and it's really geometric. So this is going to be a geometric one. And think about it, if we multiply from 1 to 4, 4 to 16, and 16 to 64, we're multiplying by 4. And since we're switching every time, we're actually going to be multiplying by a -4. 1 times -4 is -4. -4 times -4, two negatives now, is a +16. And then +16 times a -4 is a -64. Okay, second one from 3 to 7 to 11 to 15. It looks like that is an adding pattern. So arithmetic. And it looks like we're adding 4 each time. Okay, here we have 2, 4, 8, 32. So very important that we look at all the numbers, because I was getting ready to write geometric, because I was like, oh, look, 2 times 2 is 4, 4 times 2 is 8. Good, we're multiplying. But then 8 times 2 is not 32. If that last one was a 16, then I would have been ready to write geometric, but it's not. It's a 32. So make sure that it follows the pattern all throughout. So even the first couple had a pattern, the last one did not. Okay. So 12 to 9 to 7 to 5. Again, 9 minus 2 is 7. 7 minus 2 is 5. But 12 minus 2 is 10, not 9. So again, very close to finding a pattern there, but not quite. Okay, number 5, we go from 6 to 18 to 54 to 162. And it looks like that's a geometric pattern. It looks like we are multiplying by 3 each time. 6 times 3 is 18. 18 times 3 is 54. And 54 times 3 is 162. And then the last one here, we got 11, 19, 27, and 35. So that one looks like it has a constant adding pattern there. And that's adding 8 each time. So there's a couple questions on the homework. They're just going to ask you to find the pattern and say whether it's geometric, arithmetic, or neither. Okay, here they want us to find the next 3. So especially since we're dealing with multiplication here, some of these numbers are going to get pretty big pretty fast. So I recommend you have a calculator for this. So 7 to 21 to 63 to 189. So it looks like we're going to be multiplying by 3 because 7 times 3 is 21, except 189 times 3, I'm going to need a calculator for this. So 189 times 3 gives us 567, and they want us to find the next 3. So there's the first one, and then times 3 again, 1,701. And then the next one, times 3 again, 5,103. So just finding the next 3 for that pattern. All right, this one looks like it's going down. It's 576, 288, 144, and 72. So now it looks like we're multiplying by a half. And so 72 times a half is 36. These are smaller numbers. Maybe I can remember all 3. 8 times a half again. 18 and 9. So we got 36, 18, and 9. And then here it looks like we're going that positive, negative, positive, negative. So I know I'm going to need to multiply by a negative number. So from 5 to 10, 10 to 20, 20 to 40, looks like I'm multiplying by a negative 2. And so negative 40 times negative 2 is positive 80. Then I get a negative 160. And then I get a positive 320. All right, and then we got these graphing ones, which I'll do one of them here because some of these get kind of messy. So remember, this is our first number. This is our second number. This is our third number. This is our fourth number. So I'm going to graph those 4, and it wants us to find the next 3, but we just did that in the last one. So we want to graph, let's say this is my 0, this is my 1, this is my 2, this is my 3, this is my 4. And then this is 0 as well. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So geometric, this is going to be just a little more difficult because it's a multiplying pattern, and these numbers are probably pretty big. So for me to graph 112 is already off the chart. It's going to be somewhere up here. And then 2, 6 is going to be somewhere up here. 3, 3, and then 4 and 3.5 is going to be in between there. Okay, so we're graphing. Remember, first number they give you is always the first one, then the second one, then the third one, then the fourth one. Okay, here it wants us to write the formula for it. So let's pretend that we don't see right here where it says find the 6th term. We're just going to write that formula for it. So remember, here's our formula. So AN equals A1, and then R times raised to the N minus 1. So A1 for this one is going to be our first number. So 6,561. Times our rate. So we need to figure out our rate here. And it looks like we're multiplying by a third. This is why it's important that we all use the multiplying, not dividing by 3, because that's going to change our answer a lot here. So we're multiplying by 1/3. And then we're going to keep it as n minus 1 up here. Okay, let's do that for the next one. So my first number is 8. Now it looks like we're multiplying by a negative 3. Then same thing, n minus 1. First number here is 3. Looks like we're multiplying by 5. And then same thing, n minus 1. All right, now let's pretend that I see that A6 there. And so I'm just going to plug that in. So 6,561 times 1/3 raised to the n minus 1, which is 5. 8 times negative 3 raised to the n minus 1. So 6 minus 1 again is 5. And 3 times 5 raised to the n minus 1 again is 5. And remember, when you're putting this in your calculator, we're doing order of operations. So order of operations should be 1/3. Like for this first one, it's going to take 1/3 to the 5th power first, because please excuse my dear Aunt Sally, exponents comes before multiplication. So make sure that you're not putting in 6,561 times a third and then raise that to the fifth power, because that's not the right order of operations. So I'm going to do 1/3 raised to the fifth power times 6,561, and it gives me 27, and that is correct. Another good thing about these is I could just probably do these a lot faster, especially since they only want the sixth term, because they just by hand. So here's the first, here's the second, here's the third, here's the fourth. Really, if they just want me to find the sixth term, I probably wouldn't even use the formula, to be honest. I'm just going to go 2 more numbers down and figure out what it's going to be. So I started with 6,561, and I divided it by 3, or multiplied it by 1/3. Let's keep it consistent. So multiplied it by 1/3. And I got 2,187, so that's the second number, and it gave me that. And then I did it again. So that's the third, not 33. There's the third number, 729, it gave me that. There's the fourth number, 243. Fifth number would be 81, and the sixth number, like we figured out using the formula, is 27. So with some of these, I might just even do them by hand, because it's probably a little faster now that we're only looking for the sixth term. But if you go back and figure out this one, you get negative 1,944. And if you figure out this last one, you get 9,375. Okay. 16, 17, same thing, except now it's in a table. Okay. So maybe even a little easier, because they just say like, hey, here's the first term. So I get 2,916. Okay. Now we got to figure out that pattern. So from 2,916 to 972, or from 972 to 324, or 324 times 108, it's going to be the same thing as that other one. We're multiplying by 1/3, and then n minus 1. Here, I'm starting at 11. It looks like I'm timesing by 4 each time, because 11 times 4 is 44, and then n minus 1. So again, we're still looking for the sixth term on this one. So that to the fifth power, and that one equals 12. And then here we have 11 times 4 to the fifth power, and that equals, well, big number, 11,264. So you can put those in your calculator and figure that out. I'm just kind of skipping that part on the calculator. And then these are kind of the same thing, except now it's just in a graph form. So if it makes it easier, maybe just make a table, like for 18 here. I see that first number is 1 and 2. Second number, 2, 6. Third number, 3, 18. And then last number, 4, 54. So for me, it's harder to see it when it's on a graph like that. I prefer to look at a table or in ordered pairs. So same thing, our first number is 2. I can see the pattern here a lot easier. 2 times 3 is 6. 6 times 3 is 18. 18 times 3 is 54. And then same thing to the n minus 1. And same thing, we're still looking for that fifth term. So 3 to the fifth power times 2 gives me 486. So we're looking for that sixth number. It's going to be 486. Okay, same thing if we look at number 19 here. Our first number, it looks like, is 3. Our second number is 6. Our third number is 12. Our fourth number is 24. Oh, they even give us the fifth number here. And again, all we're looking for is the sixth number, so I really wouldn't use the formula for this, because I could just need to figure out one more. And so they gave me the first, second, third, fourth, fifth. I just need to figure out the sixth. So from 3 to 6 to 12 to 24 to 48, they're doubling it every time. They're multiplying by 2. I can figure out that that last number is 96 without having to plug it into that big formula there. And then if we look at this last one here, this last one's probably a little tricky as well. Let's see if I can fit it in this box here. But it looks like it's going down. And it looks like it's also switching negative. So it looks like 1 is matched with 8. 2 is matched with negative 4. 3 is matched with 2. 4 is matched with negative 1. And they even give us 5 is matched with a half. So keep going down by a half, multiplying by negative a half, it looks like. That means 6 is going to be matched with negative 1/4. Hope that helps.